Hello everyone, this is Poonam Pegde. In my previous video, we discussed the types of or the different alternatives for distributed database architecture. Today I come with distributed database design. Okay, so first we will see the design problem. In general, design of a distributed computer system, it involves making decision about the placement of data and a program across the sites of a computer network, as well as possibly designing the network itself. But in a distributed DBMS, the placement of application necessitates the placement of the distributed DBMS software and placement of the application that run on a database. So here we are focusing on distribution of a data, and we are not mainly focused on the designing of network. So this is the framework of distribution. Along x-axis there is level of knowledge, along this y-axis there is suppose axis of pattern, and along this axis is sharing. So this framework constitutes of axis, pattern, sharing and level of knowledge. So based on this framework of the distribution, the database distributed database design is formed. So the organization of this distributed system can be explained with these three dimensions: level of knowledge, then level of sharing, and behavior of access pattern. So first we will see the level of sharing. So there are three possibilities. No sharing. So each application in each application its data execute at one side, and there is no communication with the any other program or access to any data file at other side. Means no sharing. Means there may be no sharing within the different sites which are involved in the distributed system. Or another is data sharing. So here all the programs are replicated at all the sites, but data files are not. So user requests are handled at a site where they originate, and necessary data files are moved around the network. Means sharing of data takes place here. And the third one is data plus program sharing. So both data and programs may be shared, meaning that a program at a given site can request a service from another program at a second site, which in turn may access the data file located at a third site. Means both data and program are in share. So now we consider the another axis, that is behavior of access pattern. So the access patterns of the user request may be static, so that they do not change over time, or dynamic. So it is easy to manage the static environment, but distributed system is dynamic in nature, so that's why you have to think about the dynamic nature of the access pattern. On a third axis there is a level of knowledge. This level of knowledge about the access pattern behavior. Okay, the one theoretical possibility is that designer do not have any information about how user will access the database, and practically designers have either the complete information or the partial information about the access. And the distributed database system design problem is considered within this general framework. Okay, so we have to consider the access pattern, sharing and level of knowledge while designing the distributed database system. So now for designing a distributed database, there are two approaches. First is top-down approach and second is bottom-up approach. Top-down approach is suitable for tightly integrated distributed DBMS, which are logically integrated, and mostly it is used for designing a distributed system from scratch. And the nature of this system is homogeneous. And another approach is bottom-up approach. So when the database is already exists at number of sites, this approach is used. So it is mostly suited to the multi-databases. So now let us see the top-down design process. So this diagram describes the top-down design process. So it starts with the requirement analysis. The process starts with the requirement analysis. It defines data and processing needs of all the database users. This requirement analysis also identify the objectives of the distributed DBMS with respect to performance, reliability, availability, and economical feasibility. Then this requirement document is given as an input to two parallel activities: view design and conceptual design. View design defines interfaces for end user, and conceptual design determines the entity types and relationship among these entities. It also determines the fundamental functions for that enterprise environment. There is a relationship between conceptual design and view design. View design are integrated in a conceptual design to ensure that entity and relationship requirement of all the user views are covered in this conceptual schema. Now, from conceptual schema design, GCS is defined. That is, global conceptual schema is designed. This schema and access pattern information and external schema definition. So the access information and external schema information which is collected from the view design. These three things are given as an input to distribution design. The objective of this distribution design stage is to design local conceptual schema by distributing entities over the sites of the distributed system. The entities may correspond to relations. Okay, so instead of distributing the relations, it is divided into the sub relations called the fragments, which are then distributed. So distribution design activity consists of two steps: fragmentation and allocation. And the last step in the design process is the physical design. So it maps the local conceptual schemas to the physical storage devices available at that corresponding site. This design process is the ongoing activity, which requires the constant monitoring, and therefore the observation and monitoring is a major activity which is involved in this top-down design process. This is the top-down design process which is used to design the logically integrated distributed database systems. And when you want to design a distributed database system from scratch, then generally this design process is used. And the DBMS which are placed on, or the applications which are placed on the individual sites are the homogeneous, then this process is generally used. So thank you.